In this video, I'm going to show you how you can use the Cellpose plugin within Napari. So here, I use Stardist to segment the nuclei before in the previous video. Now I'm going to show you how you can use the Cellpose plugin to segment the membrane. So I'm going to open, if I go to plugin, I'm going to find the Cellpose Napari between brackets. Plugin and let me show you the different parameters actually. So here we need to define which layer we want to use. So here it's going to be the membrane. Which model we want to use. Cyto2 is pretty efficient when we have membrane markers. And then so this it's a bit trickier is when you have one volume with different channels. So here, as we use the bioformat plugins to separate the channels are separated. So here it's the channel membrane is only one channel. So if I use average all channels as there are only one, it's going to be this channel. The caveat with this is that if I want to use the nuclei channel, here I can't because it's in a separate layer. So I would have to open the image as Napari built-in to actually take into account the nuclei channel. So here I'm just going to use the membrane. So this would be possible. In that case, you would have the image with one slide that allows you to go from membrane to nuclei, and you would use, so if the membrane is the first channel, I don't remember in which order they are, if membrane is first, you would use 0 for membrane and 1 for nuclei, or the other way around. You can define the diameter. You can also actually compute it from the image. So if you hit this button, you see it went to 30.0. So actually it estimated a diameter of 30 in this image. So it's the same thing than when you use the command in Python and you estimate the diameter. And then you have sample threshold and model match threshold. So it's not the same parameters that you can use in the plugin in Fiji, for example, that was developed by people at EPFL, the PTBAP plugin. So it's a bit different. This one is not. So I tested this before, and I know that I need to push a little bit. So maybe I'm going to push too much. But I know it's probably more interesting with this kind of parameters. You can definitely use them. So sample threshold is the the threshold on your so on the model, classic parameter you have with every single plugin. Basically, if you want to have more objects, you can use a negative value. When you do that, it tends to push the borders, and you have generally objects that are a bit whose borders are a bit too far. So larger objects, but you have more of them. So sometimes it's just a balance. If you retrain a model, if you use a threshold of 0, it should work fine. And model match is same thing. It's how you're gonna push the flows. So if it's smaller, you're gonna push more of the flows. So then this is something that disappeared. So this plugin, as well as the the Stardist plugin, that were designed I think in 2022 or 2021. So early on. So here you can actually process with 4 different networks and then average them. I'm not going to use that because it's going to be longer, but you could do it. It's generally to slightly improve the results. And here then you can process the stack as 3D. And something very important if you want, so we're going to try this first. If you want to process the stack at 3D, so basically you're using the Cellpose way to do 3D segmentation, which is segmenting in X, Y, X, Z, and Y, Z. It's very important that this parameter is set to 0. If it's not there, you're going to have a this message, which is quite cryptic, but it doesn't work. And that's a bug because here you say that it's in 3D, so it should just process it at 3D. So if it's not 3D, it's normal that it's not working. But here it's a 3D image. But if I use the 0, it's going to work. Then just so clear previous results. If you process again and again, it's going to clear the results you got beforehand. I'm not going to output the flows and cell probe, but that might be helpful to actually fine-tune your parameters. You can use it. I'm not going to do this because the output outlines is exactly the output with a parameter for the contour. So you can have this directly from the label images. So I'm going to run the segmentation in 3D first. So I installed PyTorch, so it's working with my GPU, so it's a bit faster, quite faster, about 5 times faster than just using my CPU. But I'm just going to speed up video so it doesn't take too much time here. And actually, I didn't speed up video because it's already done. It's a small volume, so with a GPU, it's pretty fast. And here are the results. So I pushed the parameters, so I have cells almost everywhere. But you have something that so in my experience, I saw quite a lot of time when you do a processing in X, Y, X, Z, and Y and Z for 3D image, you have these fuzzy labels that appear. But I also know that you can definitely get results where you don't have the fuzzy labels. Again, in my experience, and I'm not saying I'm right all the time, definitely not, but in my experience, it seems that if you have data that is cleaner in the signal to noise ratio, so if you denoise your data, you probably won't face these kind of problems. And by the way, so you cannot use Cellpose 3, which includes some denoising, because this plugin was designed before Cellpose 3 came out, and with the Cellpose 3 it doesn't work. So you need to define it in as Cellpose 2 actually, and that's why we had to reinstall. If you remember, when we did the plugin installation, we reinstalled Cellpose 2 afterwards, because otherwise the plugin doesn't work. So if you want to use the denoising and everything, you can process with Cellpose 3 as a command line or with other plugins, and then visualize it in Napari. So just to show you that you can also do it plane per plane, the same way we did it with Stardist. In that case, so you can, actually it doesn't matter if this is checked or not, you can uncheck it. So here, if you uncheck it and you put 0, it's going to fail. It should fail. Let me check. Yes, you see you have an error just because you're trying to process it as 2D and it's not 2D image. But here you can change this. So in that case, you're gonna do your segmentation plane per plane, and so as XY images, and then you're gonna look at the intersection of a union between your objects, between two planes, and if it's higher than a threshold you define here, so like 0.3, it's gonna match consecutive labels. So if I run it now, that should work. Not sure here, we won't see anything, but that should work. So it's now processing plane per plane. When all the planes are processed, yes, it does the stitching, and this is what we get. So when you have data that is not that clean, it probably works better than using the 3D model. The problem here, and it's the same thing than with Stardist, is that when you have cells that are on top of each other, and here it's definitely the case with this kind of cells, it's going to be really hard for the stitching to be accurate. And so just to show you, you can look at both channels. We can look at it in 3D, and then we can also look at the segmented cells. So here, yeah, so it showed me an error message because we were looking at the contours, and it cannot render the contours, which makes sense. It would be really hard to do. And I can then look at the segmentation of my cells. And so it's it's fair. It's a fair result, we'll say that. we do some mistake. I pushed the labels, so the parameters. So here probably got. So let me check if I. Yes, here you see in there it's probably just a background, and it found some cells. But again, I pushed the labels. So one common problem here, it's not that thick, so we might not see that deep. Might not see that, but yeah, again, this, the parameters were pushed too far. So here we probably don't see it much, but if I did it on the whole plane, we would definitely see it. So here, I can probably see something. Let me check if I can navigate. So when we look at along the z direction, here we have one cell, and so probably this is a different cell. So we should have two different labels, but as they overlap top of each other, then it's considered as the same label. And so when you do this kind of stitching, it's a problem you're gonna have, all the time. So you could either retrain a model and do it in 3D, for example, use some denoising to try to be able to use the 3D model in a better way, or you could also try to do some post-processing to be able to separate cells that are touching on top of each other.